Factoring using the distributive property.
Example number 1, we're going to use the distributive property to factor each polynomial this will be letter A. I have the polynomial 12a squared plus 16a. So the first thing that I need to do is I need to find the greatest common factor. To find the greatest common factor, I need to factor out 12a and 16a. So the factors of 12a are 3 and 4. Since I can no longer factor out this 3, I'm going to circle it, but I can continue factoring out 4. Factors of 4 are 2 and 2. I can no longer continue factoring, so I circle those 2's. I'll continue working on 16. Factors of 16 are 4 and 4. Now my factors of 4 are 2 and 2, and 2 and 2. Since I'm done factoring, I can go ahead and circle my 2. I'm now going to write my find my greatest common factor. So I'm going to write the factors of 12a squared plus 16a. So factors of 12a squared are 2 times 2 times 3, and I'm taking 2 times 2 times 3 from this factor tree. And the factors of a squared are a times a. Now the factors of 16a. I have 1, 2, 3, 4 2's. 1 times 2, 2 times 2 times 2 times 2, and just 1a. So I now look for the things they have in common. I have a set of 2's. I have another set of 2's they have in common. And a set of a's they have in common. So the greatest common factor would be 2 times 2 times a, or 4a. So now our second step is to divide by the GCF. So I have my polynomial 12a squared plus 16a, and I can divide it by that greatest common factor, which is at 4a. My answer will have a 4a on the outside, and then in parentheses will be the result of the division. So 12a squared divided by 4a will give me 3a, plus 16a divided by 4a is 4. Another way my students usually solve this, once they have factored this, the things they have in common, they multiply, and then on the inside, if you notice up here, we have 3a plus this 2 times 2, which is 4. And then they just write 4a times 3a plus 4. Same answer.
Letter B. 18cd squared plus 12c squared d plus 3cd. So my first thing is that I need to factor out 18, 12, and 3. So I start by finding the factors of 18. Factors of 18 are 3 and 6. Since I'm done factoring with 3, I'm going to circle it. I can still factor out that 6. Factors of 6 are 2 and 3. And since I know I'm done factoring the 18, I circle those terms. Factors of 12, 3 and 4. since I am done factoring that 3, I can circle it. Factors of 4 are 2 and 2. And since I can no longer factor 2, I just circle them. And my factors of 3, well, only factors of 3 that exist are 1 and 3. And since 3 is a prime number, I technically do not have to factor them. So now I write down my factors of each of 18cd squared plus 12cd c squared d plus 3cd. So I have 18 cd squared plus 12 c squared d plus 3cd. So I write the factors right next to it. So factors of 18 were 2 times 3 times 3, and then I have a c times, I have d squared, which means d times d. Factors of 12c squared d are 2 times 2 times 3, c times c times d. And factors of 3cd are 1 times 3 times c times d. So I now identify what they have in common. So they have a set of 3's in common. They have a set of c's in common. They have a set of d's in common. So the greatest common factor is 3 times c times d, or 3cd. And the easy way that my students like to do this is they look at what's left over. 2 times 3 times d, which is 6d, plus 2 times 2 times c, which is 4c, plus the only thing I have left at the bottom is that 1. And on the outside, we put that factor, or the greatest factor, which was 3cd. So our answer is 3cd plus 6d plus 4c plus 1. Example number 2. Use grouping to factor. This is letter A. Have 4ab plus 8b plus 3a plus 6. So I look at this polynomial. The difference between this polynomial and the previous ones we have seen, this one has 4 terms. If I look at my first set, or my first 2 terms, I have 4, a b, neither, and I have an 8 and a b. I know that I can factor 4ab plus ab, because I already see a 4 that can divide them, and a b that they also have in common. I can also group 3a and 6. How do I know this? Well, I know 3 is divisible by 3, and 6 is also divisible by 3. So the way that I write this out, I think of a number that will divide both of these terms in this first set of parentheses. I know 4 will divide them, but the other bigger number, or the variable that will divide them, will also be b, because they have those b's in common, and both 4 and 8 are divisible by 4. When I factor out that 4b from 4ab, all I have is an a. 4ab divided by 4b is a, plus 8b divided by 4b. It's just a 2, plus the second set I can divide it by 3. It's the biggest number that will divide both of them. So 3a divided by 3 is a, 6 divided by 3 is 2. So now if you look at these, there's something they have in common. These two are the same. So what I do now is I keep only one of the a plus 2's, and the 4b plus a 3 will go in their own parentheses. How can I make sure that this is correct? Well, I can FOIL this. So if I FOIL it, 4b times a will be 4ab. 4b times 2 is 8b. 3 times a is 3a. And 3 times 2 is 6, which is what we originally had. So our final answer would be the 4b plus 3a plus 2. Example number 3. We are now asked to solve d minus 5 in parentheses times 3b plus 4 equals to 0. What this means is that we are now working with the zero product property. What the zero product property tells us to do is that we are going to make each set of parentheses equal to 0. So d minus 5 equals to 0, and 3b plus 4 will be equal to 0. So we now have to solve for the variable. So in order to solve for the variable, in this case, I need to add 5 on both sides. So my variable d equals 5. On the right, I have to subtract 4. So I'm trying to solve for d, so I now have 3d equals to negative 4. And I then divide by 3. So d is equal to negative 4/3. So I have two answers for d. So d is equal to 5 and negative 4/3.